Welcome, Renaud. Thank you so much for accepting to do the podcast with us today.
Thank you very much, and hello, Paramita.
First, I wanted to ask you is that you were here when LIST was formed, yeah?
Yes, indeed, I arrived just before the merging of the CRP Lippmann and CRP Tudor, and I really, that was very interesting and very intense period because I was starting here, and then there was directly the creation of LIST.
Where were you before this?
I was in CNRS in north of France, in Lille.
Ah, yes. Okay.
I was researcher at CNRS, and I moved to LIST through an open position that was advertised then.
And it was advertised for LIST, not one of the CRPs?
No, it was still advertised for CRP, Lippmann, and I learned just right there when interviewed that there would be this big change occurring.
How was it when you arrived here? How was it? How did you adapt to the change?
The first year was a little bit strange because, of course, there was this objective in mind. So I had to learn how CRP Gabriel Lippmann was working, but knowing that it will change very soon. However, I was integrated in quite a new group and a new department. I mean, in this department of material research and technology. And the new group was really created in the spirit of the new LIST. So I think I had no real difficulties to adapt to the new structure.
So your research, I know it's in material sciences.
Yes.
What led you to this particular domain in science?
So at the beginning, I was more interested in one specific, I would say, field which is more with physics, but solid-state physics, understanding
solid-state
physics
right.
and semiconductor physics, understanding how transistors work in our computer, understanding how these small devices we usually see but don't really know what they are doing work, and that was really, really interested in that during my high school, learning how it works and how the principles are working. And behind it is quantum physics, which is leading all this effect. And then it led me to the first part of my career where I was really interested in matters but for quantum devices, with this famous quantum computing that people are looking for currently.
So within CNRS is the Centre National de Recherche Scientifique, right?
In France.
So your research was still within this domain?
Field, yes, exactly. Yeah, so I did my PhD in this domain, and I went to Switzerland for a postdoc for 4 years, also working on quantum bits, which is this smallest element of quantum computers. And then I started an activity in Lille, also around this domain, trying to work on new materials for quantum bits.
What was your thesis on, if I
my
may
thesis,
ask?
Yeah, the topic was on the metal insulator transition in 2 dimensions, which looks very, very weird, which is indeed very closely related to transistors because this is a specific state of matter that is observed in transistors at very low temperature.
The transistors, when you say transistor, I'm sorry because I'm thinking of those small radios that we used to call transistors.
Sorry, transistors are these are the smallest elements from the microprocessors we are in our computers. So these are what we call field effect transistors, and the smallest element that makes really the logical computation. They are made from semiconductors, and you can observe very famous, very strange phenomena also in this device that are already well used in our computers.
So your research is basically about the materials that these transistors are made of, yeah?
Exactly. These are semiconductor materials, which can be a lot of, we know a lot about silicon, which is the most used material, but now people are working on other materials that can be much more efficient, like what you call arsenide-based material, or even carbon nanotubes or graphene, which are even more on the hype currently. So now there are many other materials that are envisioned, but I agree that silicon is still the basic one.
Yeah. And so at the beginning, you joined LIST as a researcher or as a
As a researcher, yes.
As a researcher,
it was already a permanent position as a researcher.
And how has your role evolved within this last 10 years?
So first arriving in LIST, my role evolved a lot because I joined LIST on a specific observation that during all my career before, it was very interesting because the topics is quite new, very interesting, there is a lot of activities around it, but I had a lack of seeing what would be the next impact of this research. And I was always a little bit frustrated not to be able to work with industry, with companies, where I would see the direct impact of my research. And that's why I turned to a different, more applied research when going to LIST, with the aim really to access to more impactful research for the society, for the industry. And that means also to work on subjects, of course, that are a little bit concrete. So I think quantum computing is quite a very interesting thing where we can see already some nice advances, nice progresses, but it's still a lot of basic research. Now I turn to more applied research, which is on, in particular, on gas sensors, but also on coatings for the glass industry, where we can directly discuss with the companies that are fabricating the products, and where we can really see what are the challenges to solve.
Quickly, because I know that the project that you're talking about, because we had a discussion. It's a European project, right? It's a big European project, and which actually has a very concrete impact on the society, or will have once it's.
Hopefully it will. The idea is really on this thing. It's on this topic of gas sensing, which was a little bit new for me when I started. I think this is also a good way to see my evolution in LIST. I started really in small project, individual that involve very small teams, and as soon as we had new technologies developed in LIST, also extending my network and my contacts outside LIST, then I decided to submit this proposal for a European project that was accepted. And this project is this ambitious project where we try to develop new type of gas sensors with advanced functionalities, where we can have better selectivity of the gas we sense. And we believe that this kind of sensor can have a lot of application in the future in monitoring the environmental gases, in monitoring also processes, because also processes need to be controlled, and gas sensors are very important. And it of course could also go up to health care, because then we can also analyze the breath and see whether the breath of people, and see whether we can detect early some diseases, but it could also be just to detect whether we are in a good shape or where we are in fit or not.
I remember you spoke about, two questions. First of all, how does your domain of research, materials, how does it relate to this gas sensors research?
So at the beginning, we worked really on the sensing material itself, which are small metal oxides, which are also semiconductors, but other type of semiconductor than silicon. These are metal oxide based on zinc oxide, tin oxide, and that have specific functionality because they can interact very well with the gases. And in that sense, they are very sensitive to gases, and they are very interesting in that sense that they can be integrated into microelectronic compounds. So they can be really miniaturized to be integrated in mobile phone or in very small devices.
Coming back to your personal journey within LIST now, so how has it been working with others, especially other teams?
I think in this direction, I would say probably the Ambitions project is also quite a very good test bed of this kind of collaboration, because with the new structure of LIST with 12 units, I realized that I'm involving research. Researchers from LIST involved on the project are coming from 5 of these 12 units.
Oh, wow.
So this is quite huge, which is, I think, quite a challenge also, because it's true that each unit will have a specific target, a specific goal, but I would take this project more as a teamwork. So in the end, I'm not thinking whether one person coming from one team or from one group or one unit. I think, okay, we are having some regular meeting within within LIST, even outside the regular meeting of the project, so that we can also feel this team spirit and try to work together to work efficiently. But it's a big challenge. It's a big challenge. I mean, we will see, I think, with this project whether it is a feasible challenge in LIST. I hope so, and I guess it will. But I agree this is a big challenge because, of course, each researcher has also some direction from its unit, and sometimes it might be a little bit in conflict with the direction of the project. But that's an interesting thing to follow.
To observe.
Also to observe, of course.
Yeah. And if I ask you what has been, over the last 10 years, if there has been one highlight or one memorable moment for you, what will it be?
Yeah, from my research, I mean, one of the most important, I mean, let's say, the most exciting project I've been working on is on a collaboration with a company from Luxembourg, which is former Carlex and now has been bought by Webasto. It's a glass company which is doing windshield for cars, and we have been working with them on a very ambitious project. Is somehow to work on coatings on glass, which are aimed to reduce the heat transfer from the sun to the interior of the car.
Oh, yes, I remember.
This is infrared reflective coatings.
Or on the windshield of the car, right? On the windshield
of the car, exactly.
Yes.
And this project was very specific because it was very ambitious. I have to say, we wanted somehow to provide new processing for this kind of coatings so that they can facilitate the process of the glass. They can reduce energy consumption. They can reduce the material consumption, and we wanted to do it a smarter way. But I think this was so intense that in the end we had many very, very interesting scientific results on it. And then all the people that were involved in the team were really keen on working on that. They were very proud, very involved in the project, which is often quite difficult to achieve. And I think this is this combination of having a real ambitious goal, strong commitment of the company within this goal, and also strong commitment of the team in trying to reach the performance, that in the end we had very nice results. And we were very proud of this project.
If a new researcher who's listening to us, an aspiring scientist, they want to join LIST, how would you recommend the institute to them?
I think LIST is very nice institute in that sense that it's not too big. So that means you can really develop this collaboration within colleagues that are from different fields, different background, and combine them to build a project which is very original. And I think this side of the institute is quite a strength, because you can still work with people that in a bigger institute you will never see. We're thinking about other RTOs that are much bigger, where I would say the department and the activities are quite split, even on different sites, different region of the country. Here we are all together, we can speak together, and so if for the future I want to create a project where I need a certain competency, I can very easily speak with someone from next door and include him in or her in the project, and have a very fruitful collaboration. That's my main message to newcomers from LIST.
Excellent. So we'll end our episode. I'm going to ask these 3 questions to you. And so what is your favorite LIST innovation?
I'm very, very impressed by the Maxims technology developed by the SIPT unit, where they developed this small secondary ion mass spectroscopy to be integrated in microscope.
Yeah.
This is a very, very big example of how you can transfer technology to product.
Perfect. And one colleague from who you've learned the most of, or who has influenced you the most?
probably the one that has influenced me the most, but at an earlier stage of my career, is Damien Lenoble when he was group leader.
Yeah.
In a way, he'll teach me how to discuss with companies and having a discussion which is always, because it's always a little bit of a fight at some point. And
negotiation.
Yeah. And I think he was a very good teacher for that.
And a book or a podcast that has inspired your work or inspires you?
Yeah, so the book that inspires my work, not scientifically, but more on the way I'm doing research, is the book from Carl Gerassi, The Cantor's Dilemma. And the book is dealing about the research activities, but more on an ethical point of view, rather than really scientific. And I think this is a very interesting book to read for researcher, because it demonstrates how far a researcher can go if he wants to become famous, and how far can you go to try to demonstrate that your idea is correct against the others. And I think it's quite interesting, because now research is more and more pushed to performance, being the best, being the most famous one, and it can be very easy to ask collaborators to change or modify results to get to the final goal. So that was quite a very interesting one too.
For the ethical guidelines of research.
Yes, and this
Excellent.
is a good one to think, because it's quite realistic also. Every researcher will know what can be the risk there.
Thank you, Renaud. Thank you so much. And I hope that your project sees the results that you're hoping for. And good luck, and see you later.
Thank you very much.